think we're live, but we're going to check if my audio is potato quality first. Um, Go ahead and load what I want to see. Come on, Twitch. Show me what's live. Or not. That's fine too. Well, in the meantime, welcome to Global Hack Week Cloud. I think we're at day 2, which means we have my stream today, and we'll be doing a smart home starter kit. And for most people, that means like, oh, hey, let's do, cloud technologies. And I'm like, no, let's do IoT. Because I miss doing hardware hacks, and I think maybe we could, have a resurgence of it. There's still an ad on Twitch, so I can't confirm if my audio is potato quality. If people in chat could tell me how my audio is coming through, apparently it was really bad at the last stream I did last month. Hello, hello. My loyal friends are back. Ish. Let's see. Wow, this is a really long ad. Twitch plus. Well, we're gonna assume it works for now because no one's complaining. I also zoomed in super big, so hopefully we can see things. And then let me go grab our link for today. So if you haven't had a chance to register, go ahead and go do that. I'm waiting to give people an extra minute to show up, get comfy, make sure they've gotten a chance to get water. This ad is still going. Love that. I'm giving somebody money. I just don't care who at the moment. My very much not. You know what? Is it not? No, there we go. All right. Let's see. I just want to know if I sound like garbage. Okay, yeah. I forgot I had the volume super low on top of already muting Twitch. All right, we're good. Cool. So, what does that mean for y'all as far as what we're doing today? And I forgot to zoom this in. A+, already off to a good start. Right, so I do know that one of our other coaches, Alberto, is actually already doing a whole series on Firebase, which love that. Definitely check his stuff out because I think that'll greatly help you figure out a little more of what's going on behind the scenes. I will personally admit I learned Firebase yesterday as I prepared for this workshop. I definitely know Internet of Things a lot more than I do Firebase, and so I'm actually... The reason I'm doing this workshop is because I want to do smart home things. Therefore, everyone else should do smart home things. Great planning. It's just a fantastic planning. But the voice is not coming through well. Rats. Maybe it's just... How about now? And let's go all double check my settings. It should... Oh. That's fine. That's fine. Audio. Mic volume. Is that any better? Okay. Other people are saying it's kind of okay. Some people are saying it's echoing. Peanut Butter is napping in her tree in the other room. Now it's too loud. Got it. Cool. Let's go fix that. That's because I turned it up on purpose. I should not have done that. Okay. Great. Sorry, people. Nothing like mic issues. But yes, Peanut Butter is, I think it matches the energy that's needed to answer this question, which is that Peanut Butter's doing great. She was very upset that I left for HackCon and put a hole in my leg with her teeth. But that's what she does because she likes to have friends at home, and we were not home, and that was not okay. She is better now. She is less angry. She had playtime with Wormy the last few days. Wormy is sacred. Wormy is a little fuzzy toy with a bell on it that she really likes, but she's doing good. All right. People have taken some time to join in, so let's actually get started because I do want to get us in a really good spot for the next stream, which I think is Sunday, because we'll be doing lots of fun stuff with hardware. But like I was saying, for those who... Oh, no, I'm so sorry. Oh, the delay in stream kind of sucks because other people are trying to fix things and I'm trying to fix things, and it's just bad timing. So I fixed the volume. Hopefully it's fixed now. I'm sorry to people's eardrums. I hate when that happens, but that's what happens when you have a nice mic and not a garbage mic that's just a headphone mic. There's always going to be issues. Also, my PC's been acting up. But anyway, what we're doing today is we're doing smart home things because I want to also do smart home things. I was mentioning for those who came in that Alberto is doing a whole set of streams on Firebase, so definitely check his stuff out if you find that you like using Firebase. I'm really only using it to just store my data from my Internet of Things like my sensors or other data that I want to send back and forth, in which case we might use like another, we'll think about it. Point is, we're using Firebase for really simple things. And I did a lot of pre-work just to make sure that I could prove that this was possible. There's a number of tutorials that I referenced, but generally if you Google like smart home, Firebase, real-time database, you get a couple different tutorials that are actually quite helpful. Unfortunately, what I had to do was cram like 3 of them together to get this to work, but it works now. So we're gonna go through it. So these are all my notes. One of the things we're going to do later as part of like the last stream is we're going to build a web app, which will visualize all of that data that we're going to be collecting from our smart home pieces. So that way we can actually do something with it. Because what's the point of having a database if you don't do anything with it, right? Like, is it going to be a dashboard? Is it going to inform decisions? Is it going to do automations? Hint, hint. That would be a great goal. I don't actually know what we're gonna do with that. So I've blacked out some stuff because that's like things I don't want to dox myself with. But as for what we're doing, we will be talking about what's a hardware. People kind of get spooked by hardware, and I've come here to tell you it's not that scary. It's still scary, but not that scary, because some of the concepts have different forms than what we're used to when we're doing software approaches and things. And so people get really intimidated because like, oh no, a breadboard, like I need to know how to do power and grounding and like, what if I break it because I wired things wrong? Well, the short version is that there are simulations actually out there. No, this is just our like informal workshop checklist. I never really share these because we never get very far. But you're welcome to watch the videos after the workshop is done. They'll always be up on the YouTube channel for sure. We've been having issues with Twitch for some reason where not everyone's recordings have shown up. Or maybe it's just like a history thing, but YouTube for sure has all the past Global Hack Weeks. So you can like pause and see what I've done at any point. I try to move slowly through this. Kind of. We actually will be using the Arduino IDE because I'm lazy, and also because it's actually very accessible, but we're actually using ESP32s or ESP8266s, which I will show you. They're these little microcontrollers. I have one on each end because I didn't know which one was going to work depending on what cable I had. Yeah, so these little microcontrollers are also like a sensor here that I was going to wire up and then ran out of time. The point is you can choose from different microcontrollers. These are just some really popular ones right now in the IoT crowd, smart home automators, and other like small but mighty, without going Raspberry Pis mighty, like approaches to things. In the past, people have done like much smaller microcontrollers. Like there's like the tiny MCE series microcontroller, etc. There's also like the stuff that comes out of Microchip, but these tend to be the most accessible like pieces of hardware. Like you can get them on Amazon, right? And with the chip shortage that tends to happen, ESPs are pretty nice in that regard because Raspberries are hard to get a hold of. This is actually not my 3D printer. It's my friend's. She got it over Christmas and it wasn't working. There was a lot of layer shifting. So I offered to help fix it because I don't have a 3D printer and I wanted to see if I wanted it. The answer is I don't want that one. I want the nice bamboo ones or something. But that's a project for later. Oh, perfect. So you aren't required to have any of the hardware that I'm working with today. This workshop is very much meant to be an introduction to hardware. And if you are interested and you're like, I feel like I want to tackle this, then go out and buy something. I do know that not everybody has one. If you happen to be at certain MLH events, I know that we definitely gave out microcontrollers at those events, and that would have been your chance to get one. But I do believe we are a partner this year. I haven't double checked because I haven't gone to an event yet, but if they are coming to your event, then definitely snag a ESP32 from them, because it's like for free and you don't have to wait for shipping or anything like that. And, opportunities, right? Or just get it because, free things. Who knows? But if you don't have those things, there are simulators online to do hardware things, whether it's wiring or figuring out what you want to do. And I'm just going to prove to you, Arduino wiring simulator. In the wake of COVID, there's a lot more simulators that came about. So you have things like Tinkercad. There's resources in the Arduino forums, which I know this is super small. Let me zoom in. Tinkercad, I don't have a recommendation, but if somebody in chat has a recommendation of what they've used, please paste it. Circuit.io, I've definitely heard about, but there's a lot of people asking who use that as a chance to just prototype, does this work, before they go and buy some of their stuff. Alrighty. So again, DigiKey even has there's so many resources. There's the Arduino Playground, and people have taught with it too. So definitely check those out. We're not going to get into wiring specifically today because I think that is a monumental task for the next workshop. I really just want us to have fun and get started. I said it's not public. I don't make this accessible. I just say go watch the video because this is again our checklist of what we're talking about. Okay, so I've told you about hardware. It's not that scary. There's plenty of resources. Moving on. We've done that. And then IoT, Smart Home, HomeKit, Hasio. There's all these names that I've kind of thrown around or you've seen on the screen this time. And IoT is Internet of Things, which basically means something like these microcontrollers coordinate with these sensors, which are itty bitty, and they send out data. And so Internet of Things is what do you do with that data? How do you connect things to the internet? And so we already have IoT dishwashers and fridges that tell you hey, your water filter is going to expire, or your dishwasher is running out of rinsing liquid or whatever it's called. All sorts of things. And that is Internet of Things. It's already integrated into a lot of our technologies. But what if you're but I don't want to buy it? Or I don't want the thing that you're saying. What if I want to do it myself? Because we are hackers and we get frustrated with what's out there and decide to make our own. So if you have things like the Google Home Minis or any Google Home accessories, or Apple, I think also has accessories that I can't remember because we're not an Apple house. We have Apple products, but not like that. But HomeKit is what actually connects them. The Google system has its own. There's the Hue lights from Philips. There's a variety of ways that people have made fancy lights on their desk that if they're in a meeting, the lights turn red, or I remember during COVID seeing somebody had made, what was it, an on-air sign in their home workshop. And basically when they had a meeting, the on-air sign would turn on outside of their office so that their family would know, don't walk in, I'm in a meeting. And it was such a creative solution. All of that uses the internet and it connects a thing to the internet. So the other thing is Hasio, which is an open source approach to connecting all of these things on one network, because I mentioned a lot of different things: HomeKit, Philips Hue lights, your dishwasher, your fridge, etc. What if we didn't want to have all these different apps? We just wanted one collective system, because there's a bajillion apps out there. If your garage opener probably has an app if it's new enough. So with that, we're gonna just kind of combine some of this stuff into what if we wanted to make a garden tracker. Yes, actually, yes. Echo Dot, Amazon, AWS, all this stuff would come under this. The only reason I went GCP, Google, etc., is just because that's what I have in the house. I do actually have an Amazon Echo, an Echo Dot, but I don't use it because I'm not ready to have conflicting services talk to me. And that's super cool. This is a great way of integrating things where you have a water tank, you're wanting to look at this stuff, you don't want to pay for it, and you just have enough knowledge to just see hey, what's going on? Can I get a notification when the water quality dips, for example? There's ways to integrate it with your phone, with your websites, your home Wi-Fi, etc. So lots of opportunities. So my goal is to get you started. If you aren't familiar with any of this, how do you get to a point that you can at least collect data and do something with it? Which is what we're going to be doing. We'll be setting up that database. walking through the code that I pulled together across tutorials just to test that, hey, like, does this database even work? And then next session, we'll talk about integrating the sensor and or actuator, which we're going to actually choose today. So I have a couple sensors that I managed to find in the large amount of things that I have in my office. You don't see it, but there is a closet. Half the closet is software because it's full of yarn. Because I do crafting. And the other part is full of hardware, which is like sensors, actuators, wires, and all that stuff, because I also do embedded systems. So all that to say is I have lots of sensors, and I'd like chat to pick one because I want to prep this for the next workshop and show you, like, this is how I did it. So I have a raindrop sensor, which is great for detecting things for plants. If you want to start a home garden, but you're not home all the time, maybe you're like, hey, if it starts raining, I don't need to water the plants today. Like, and it controls like when you water things. Maybe you want a temperature sensor. So like, I live in a very hot area. I want to know how hot it is. Like, what is the air temperature near my plants, for example? Because if it is that hot, maybe I need to like move them to the shade. Maybe I need to get like a warning, kind of like when your phone goes off and tells you it's too hot. Again, I live in a hot place. It's also very dry. Maybe I want to see, like, is the humidity really, really high that day? Like, am I expecting a rainstorm? I actually just remembered I have a barometer, which is for pressure. So this is the combination of like these four is great for detecting a rainstorm, even if the Weather Channel will tell me. Again, I live in a hot, dry place that if the rain is falling, it may not even reach me. I would like to know if I'm getting rain or if I'm being lied to. But I also have photoresistors, sound sensors. This is great for like home security. This is great for both gardening and for detecting like, hey, has like the sun gone away? Do I need to turn on the lights for like outside or inside my my house, my office? So pick a sensor and I will put it together for the next workshop. And while you think about what you'd like to do, like what you'd like me to do, really, that then we can like, I can again show you it's not that scary. It's just kind of scary because it's the unknown, right? I also have actuators, which are things that interact with the real world or reaction things. Like, so there's a single color LED that I have. I have plenty of different colors of LEDs: red, white, blue, green, yellow, etc. But maybe you want like, okay, so we have a vote for a sound sensor so far. But as far as actuators, these are, let's say I want to simulate something because I'm not ready to fully test out what I'm doing. Like, let's say if if the temperature goes above 100 or 40 C, or give or take, if you're Fahrenheit versus Celsius, maybe I want an LED to turn on before I actually really hook it up to something else, or just to confirm I'm getting those values, right? Like, before I send it to the database, maybe I both send it to the database and I'm also like keeping track of it on my microcontroller. Maybe I want like specific colors to say like, hey, you know, if the temperature is above a certain amount, then change to this color. If the humidity is also above a certain percentage, change it to another color, and so on and so forth. So I could split that into multiple LEDs where I have multiple LEDs up, or I could have a range of colors if I'm using a nicer LED that allows me to do multiple colors, in which case I can get more custom variety instead of just like pure red or bright blue or otherwise. There's also servos, which are kind of like motors. So let's start with the motor idea. A motor goes in one direction. It doesn't really switch directions because that's how you break it. A servo can go at certain angles within like a limited degree, but it can't like go all the way around. And so there's different ranges of motions. But servos are actually really commonly used for robotics, where it's used to mimic your elbow. It's used to mimic your wrist, because you now have two servos where you would mimic the ulna, your bone that like rotates your wrist, as well as your wrist being able to move up and down, which is the second servo. Servo, switch the O and the R while you're at it. And that's different. So a motor would be, again, going around. I do have mics. I have mics. So a mic is both an actuator and a sensor, but like a sound system that like sends out voice or music or something. That would be an actuator because it's reacting to whatever. So maybe, let's say we hear a sound using that sound sensor. A mic would go off, or we would use the mic to say, hey, or like a speaker actually is a better way to put it. Let's put speaker. A speaker would be like, hey, intruder, don't be there, right? Or like if a kid is touching something that shouldn't, maybe you want an alarm to go off, like especially if you have a nice display case. You have a Yes, I really love the Philips Hue system. I just hate working with their app. But it's a great RGB actuator, such as, again, when that person was having meetings during COVID and they turned on their lights. I really wanted to do that. I just couldn't get it to work with what I had at the time. I think I'd be able to do it now. I do have Philips Hue things. I'll see if we can integrate it on Workshop 3. How about that? We'll consider it. If I can hook everything up, we'll see. But then you have things like switches or buttons. Like maybe we don't want things to start sensing until we've clicked a button and said, go ahead and start. Or maybe we want things to stop collecting data or sending data when we've hit a button. Basically turning it off and on. Joysticks in case we want to move something around. A solenoid is like something that like can push things. Like it's just like a little like, I don't know how to better describe that. I've just always understood it as like, it's a little thing that just kind of like punches out. You have piezo buzzers, which is another sound maker. I actually have an old PC fan from when I rebuilt my computer. And a potentiometer is something that changes the resistance of things as you use it. And so you could change the intensity of an LED, for example, which it can be both a sensor and an actuator depending on how we want to interact with things. So are there any other votes for other sensors that we might want to play with? We currently have one vote for a sound sensor, which I've actually never hooked up. So I'm actually curious to see how that would go. Gonna give it a bit because delays are real and it takes a bit. Great time for a water break. Any other votes for a sensor? Sound sensor sounds good. I like that. Bad pun. Okay, so we have sound sensor. Do I have that with me right here, right now? I think I pulled it off of. Yeah. So here is our sound sensor. If it will show up. So this is very fancy, just because there's a lot going on. But as you can see, there's a little speaker on the end, like a little mic. So this will be our sound sensor. I have a very fancy temperature. These are like Arduino kits that I have. I also have like legitimate things, like the like base version of them that aren't so pretty. But this is just nice if you're getting started because it has like labels on it, like your signal, your VCC, which is like where is the voltage coming from? Ideally like 3.3 to 5 volts, and then you have your ground. But this little doohickey, the black like piece, is actually the original like sensor. These boards just break things out for you and make it nicer to wire, and even do like any of the resistance things that you need. So it's very nice if you don't have all the materials. I, to be honest, could not find my original sensors, so that's why we're using these breakout boards. Plus, I think it's just easier to like work with, see, etc. If I do find them, I've always used them. But as far as actuator, somebody said a servo. And so maybe for the sound sensor and temperature sensor, like if it's too hot, we want to close the door, right? Or if, a sound goes on, we want to make sure that, again, the door is closed. Like, is it open, etc. So we can use it as a way to simulate a reaction in the environment that we want to see. Eventually, we would connect it to whatever other pieces, but it's a great way to visualize what's going on. So sound sensor, temperature sensor for me and for sanity checking. And then servo is what somebody said for an actuator. Again, if anybody comes in the chat late and has ideas of things that they want to do, I'll take those into consideration. All right, we did the fun part. Let's go set up our Firebase stuff. So if you're not already in Firebase, go ahead and go to firebase.google.com. The only reason I chose this is I've never used it. I think I did AWS for the last cloud Global Hack Week, and I was like, well, I've never used GCP, so let's do it. My range of decision making is quite limited, as you can see. So I'll give you a chance to go ahead and open up Firebase. Make sure you're logged into your Google account. We'll be using your own. And once you're ready, go ahead and click Go to Console. It will take you to any of your existing projects if you have. If not, it'll show you like an empty project space, and we'll tell you like, oh, hey, create a project. As you can see, I made a demo just to make sure that this worked. which I will actually demonstrate. And so you can see what our end product for today will be. Meantime, all right, so I already set things up. Like I said, it's super duper zoomed in because I wanted people to be able to see things. But what I ended up doing was I set up authentication and I set up the real-time database. And the reason for the authentication is there is some limitations with IoT, which is if you are working with Internet of Things, that means they need access to your Wi-Fi. And if your little device with its minimal security has access to your Wi-Fi, who else has access to your Wi-Fi? And who else has access to your database? Critical questions. Good to have. So what that means is we set up a way that only devices that have the login can get into things instead of just like anyone who connects can get into the database. Because then like what happens if somebody like deletes your data, right? Or finds a way to figure out what's going on in your house and mess with your automations, or worse, do other things with your Wi-Fi. So rule of thumb with IoT that I am not covering and that I have not done in my home yet is to set up a separate Wi-Fi network for your Internet of Things. That way they're never actually connected to your main network and therefore never risking your security in that regard. Depending on how intense you want to make this, you could set up a whole different router, you could set up a VPN, you could set up a firewall, etc. The only reason I know these things is because that's what my dad did, because he flipped out about the security of his home with all the smart homes, Googles, Alexas, and things that were entering his house. My dad is more of a privacy nerd than I am, which is great because I learn a lot of things, but it's also like I don't have the money to buy a corporate level Wi-Fi router that will let me do the things that you're asking to do. Good for you. Cool. I will one day understand that. That's not today. So there's always going to be someone in your life who's going to be like super privacy nerd, and it's great because you get to take all their tips and be like aware of things that are going on that you should be, careful about. I am careful within reason. There's a limit to my understanding and what I can do just because I don't have much time. I'm a PhD student. I don't have time. I'm trying to defend this semester. It's not going well. Anyway, so with the real-time database, you'll see that I have this URL and that I have this test value. So this is actually a route that I was using along with these specific values are also routes. And this is, again, this tutorial that I jumbled together across the internet. But they said, we're going to post values to the URL of the database /test/float and /test/int, or we're just going to keep changing it to prove that it works. So this is how you could update values. Ways that I've seen people do this is that they might have a timestamp for the path, and then they'll have their data. So this is great if you have multiple sensors. So let's say you have all the sensors I mentioned. You have a photoresistor, you have humidor, you have raindrop, you have barometer, you have temperature, and you have a sound sensor. And you want to get the values all at once, package it up, and just send it in one giant package, in which case we'd have timestamp and then all those sensors. And it would, instead of being named float, would be like temperature. And then we would have the formatting or whatever. So I also included some rules talking about security where only, this is actually wrong. This is only authenticated users can read. So originally the default rules on a database are actually going to be something like .read everyone, .write everyone, which is dangerous. Don't have that. Don't do that. This is the URL that we're using or the path that we're using for the specific values that we want to read and write. And these are the permissions, of course, where specifically I'm looking for anyone who's authenticated can do stuff. If not, they can't. And this is, again, bare bones security. So good to come back to this. But again, we're just demoing what we're going to do today. I'm not going to show you authentication because I have an email in there that I just don't want to show just yet. But we'll go back to the project overview. There's also an app here. And so what I ended up doing was, again, this is for our workshop 3, but what if you wanted to do something with your database where you wanted to actually see what's going on, maybe get charts of the values that you're getting and see like the temperature over time, which if we could include those timestamps, that would be helpful. Or when did sounds occur? Was it mostly in the morning when the birds are awake? Or was it mostly at 5 p.m. when everyone's coming home and driving into their garages and you hear all those noises? Or is it at 3 p.m. when the train goes by every day, right? So you'll start to see trackable things in your neighborhood depending on where you put your sensors. Okay, so again, bare bones, this is what we're doing. So let's go ahead and go back to that Firebase console. I'm pretty sure by now you've opened this, you started a project. So we'll go ahead and create a project. We're going to name this GHW Cloud because I want to keep this unique. Obviously, we now have an identifier. Go ahead and scroll down, and we're going to go ahead and hit continue. We are not enabling any of the analytics because we frankly don't care and don't need it. We just don't. This is really much it's a proof of concept, just to see how things work before we really get into doing any of these things. And we'll let it figure out what it needs to do eventually. I didn't realize it would take this long. I don't remember it taking this long yesterday. Alrighty, let's go ahead and hit continue, and it'll load us in. And so this is what it would have shown you if I hadn't already made the app, just to again test. But if we wanted to make an iOS app or an Android app, maybe to see all the things that are going on, we could do that. In our case, we're eventually going to go ahead and set up a web app. But it looks like you can do a lot of other things. Like maybe you wanted to create a natural environment using Unity or Flutter. Lots of options. You can see that I'm not using Gemini for right now. I actually have not used it, and I'm not willing to try it out just yet. But you can see that there's lots of options here. Yes, the video will be uploaded to YouTube once the workshop is done. It's actually currently live on YouTube right now. All right, so authentication, we're going there next. But for now, let's take a look at what we've got. We have lots of different options. We opted out of those. And we're not really looking at any extensions, but this might be useful for like BigQuery. Let's say we had our data over the course of a year. We're like, hey, I really want to just see what's going on. I want to get a feel for things. I want to see like what were the outlier days. If you're looking at using this for managing your power consumption or seeing where there might have been really hot days that may have risen the cost of your power, which is something that I do, I would export things to BigQuery to start running analysis on it. So lots of opportunity again with that sensor data to be like, what's going on in my house or my garden or wherever it is that you're setting this up. Okay, like I said, we were going back to authentication. So we're going to go to build, and we're going to go to real-time database. So that way it'll just go ahead and open it up. Yes, it is. Go ahead and create it. I'm sorry. I said we were going to do authentication, and then I lied and we did database stuff because I thought it was easier. So for me, I'm closest to the US Central one. For you, it will probably be different. Please choose whatever it gives you because it will just give you a location that's closest to you, which is what you prefer. The farther away this database is to you, the longer it's going to take to, I mean, again, minuscule, but still unreliable. The longer it's going to take to put you in, your data in the database and then for you to retrieve it and actually do something useful with it. So think of it like ping, just choose the closest thing. And then again, options, you could make it private by default where your read-write access is only granted by your rules. It could be that instead we go with our test mode where anyone can access things. And so for the purposes of this project, when I did the demo for just testing things, I put it in test mode. I did eventually change the rules themselves. So we're going to keep going with that because it worked. And I'm not about to break things so early on in our stream. We're literally 30 minutes in and we have, an hour and a half to go. And I'm not willing to break things. But you go ahead and start with test mode, especially if you want to delete it later, whatever. Again, solve any hidden mystery things. But if you want to try locked mode, more power to you. I do have the rules ready to share. So we'll see how that goes if you want to try it. And we're going to go ahead and create it. And so it's going to give me this URL that we're going to use. So I can go ahead and create paths. So that to mimic the path that I had, it was something like, test/int, and, it said 5. We could do that. And you can see that once again, it's giving us that value. I'll show you another example. I'm just deleting it. So that way, let's say I wanted to do temp sensor, and it's going to be 5040 C. I wonder if it'll do. So you can see that it's automatically changing what the expected value is. So my temperature sensor data is going to send it to me in Fahrenheit, probably, unless I do the math differently, in which case it would be Celsius. Currently, it's outrageously hot, probably. It's outrageously hot, probably. So Okay, this is a great question. Are these functions exclusive to Firebase, or would this be possible with another database like MongoDB? Good question. I didn't Google this, so let's go Google it. MongoDB ESP32. We have a initial question in the board. Specifically, what I'm looking for, they have an endpoint. They're This is their code. Debug, compile. Solving their own problem. Okay. It looks like. I would say you could. I would say you could based on this this little forum. There's plenty of resources so far. This is the same one, actually. Cute. I see. Okay, yeah. What I'm seeing says yes. So you could do this with Atlas, because again, it's another form of cloud, where they're using an MQTT client, where MQTT is another way of sending and receiving data. It's specifically called subscribing and publishing. This type of data transfer is great if you want to have multiple devices access something or multiple services access something. Let's say you had a built-out project, and that you wanted people in the same Wi-Fi to be able to see updates from your garden, that they wanted to just get whatever the current thing's going on, kind of like what we're describing right now, rather than saving that value into a database like I'm currently describing. It's just sending you real-time data. So I'm trying to think of a better way to explain this. If you subscribe to an MQTT topic, you will therefore get the updates. So you will get the updated values. Let's say the temperature is rising from 9 a.m. to 12 p.m. It goes from 85 to 110. And every time you check, it will give you that most recent value. On the other hand, your sensor, for example, the temperature sensor connected to an ESP32, maybe it sends the new value every minute or every hour, where it's like, what's the temperature value? Oh, it's 90. Okay, go publish that so that way my subscribers can see it. I guess I would think about it a lot like in Discord. Whenever I make a message to the Global Hack Week chat or announcements, I say publish to my followers. So that is another example of MQTT-like behavior where I'm sending a message instead. All that to say, yes, it seems like you can absolutely send data back and forth using MongoDB. Again, the expectation, though, is that your microcontroller connects to the Wi-Fi. And because it has an internet connection, it can send things wherever it needs to go, either using GET and POST requests, an MQTT server where it's like publishing and subscribing, or that you are sending it directly to a database, which requires API access, which, again, GET, POST, etc. So short answer, yes. Longer answer, choose wisely. You do the research to see what other people have done, basically. I didn't choose MongoDB just because I knew that if I wanted sensor data, I want almost every second, if not every minute. And that can definitely overload a database that isn't prepared for it. So which is why I'm choosing real time. Yes, you can absolutely use relational. In a way, this will be a relational database. Yes. I mean, it's kind of, actually, I don't know. Let me not make claims I don't know about. Let's go Google it. Firebase is not a relational database. Today I learned. Good to know. I had no idea. I should know this. But yes, you can absolutely use a relational database. You just have to set up the schema. So let me use our to-do list as an example schema. Oops. Relational database. I would have sensor name, and then I would have, that would be like a string or a var let's call it 10 characters. And then I would have whatever the value is, whether it's int, float, because then generally there'll be that. It just depends on how am I sending this from Arduino or other. And then maybe I might have other information or whatnot. So I could have a table that is per sensor. So maybe it's like temperature, if I can spell, temperatures. And that's going to have, timestamp and value. And then I have my humidity, which is going to be timestamp and value. Or I could do it all in one, which is what I'm describing up here, where I have, again, sensor data, and that will be sensor name, sensor type, maybe if I need to clarify, like if I need to know, like, what is it going to be, float or int. And I'm just spinning this up off the top of my head, so don't quote this as God or gospel. But I would need to have the structure established, which is one of the drawbacks to using a relational. But if I know what sensor data I'm getting and it's not really going to change, then like I can set up a table. So then sensor value. Given that I will mostly have sensor values that would probably come across as a float, or I can convert into float, I would actually prefer to just have everything be a float, because then I don't have to worry about cutting off values if I were to just have everything be an integer. So single table versus multiple tables. And then I could access it as I normally would access a relational database. Yes and no. On the one hand, it could be, if that's a very like efficient database where I have my tables set up in an optimal way to get whatever data is that I'm looking for, versus like, how do I put this? The way to determine what database works for you is what database you understand, first of all. I know both. And so like, as you saw, I very quickly spun up table schemas, but I can also use non-relational where I'm like, oh, the path is this, like it'll look something like this, and then move on with my life. And I can edit it whenever. So if I need that flexibility, I would choose non-relational. If I know right off the bat what I need, or like adding things are very easy, I would go relational. It just depends on how much structure I need in my data. And the second thing I would consider is, or the third thing, I guess at that point, I think it's the third thing. Sorry. The third thing I would consider is how fast can I write to the database, and how fast can I read from the database? Because you risk locking up your database if you are reading and writing too quickly, but it depends on the quality of the database itself. And that is something I'm not super aware of who is best for that. But the reason I chose a real-time database in Firebase is because I'm making the assumption that it can handle fast read and writes, or at least fast writing. There are different types of databases that have different abilities or strengths that would allow for you to choose. So like there is a, there was a database I learned about. What am I looking for? I'm looking for, I want graph. There's a type of database that's really good at computations, or like accessing already written data, but it's terrible at writing to it. Like it's great at reading, but it's terrible at writing. Good for reading database, bad for writing. What is it? What is the name of the database that I'm thinking of? I read about, what am I? Was it Redis? Is it Redis? That doesn't make sense. No, Redis is for real-time stuff. Who am I? Huh? Corporate database options. Who did I read about? I'm gonna table that, because there's, maybe it is Redis or a form of Redis. There is a database out there that is extremely good at reading data quickly, processing it, sorting it into documents, etc. It's a relational database, but it's terrible with fast writes. So I would never use that database for sensors, because if I want things on a per second basis, and so I'd really have to check what is the response rate and write rate and read rate depending on what I want to do. If I wanted to write frequently and not read frequently, I would choose a database that I would be able to do that. And vice versa, if I want to read faster than I write, then choosing optimally for that. Because if I'm doing like 500 reads because I have 500 different people trying to read my database, but I'm not writing every second, I may be writing every minute or every hour, then I, again, choose accordingly based on your needs, not necessarily about what's more efficient for the, like, it depends, hand wavy, etc. But yes, it's a good question. That's a really good question that I don't have a concrete answer for. I'm sorry. But again, very good question. Where were we? We were testing. I was showing you the database. We set it up. Oh, right. The default rules. Right now it says anyone can write anything from the current day. We're not in October, right? It's September, right? I really hope it's September. Yeah, we're good. It's September. I don't know why it says. Okay, point is anyone can read and write. We're going to change this. The rules that I have here, let's go look at that. I had mentioned that they're very specific, where I have the test path and that I have anyone who's authorized can read or write. If I wanted to change it, I could say, I think it's like just null. If I want to say like no one can read it, but only writes can happen, or vice versa. Maybe I have a database and I'm done collecting data. Like I've unplugged my smart home and I'm like, I just want to look at the last however many long years of data, in which case I never want to write again. And I wouldn't want anyone to come through and write something because they had access to my system for whatever reason. There's also a way that is not here where you can actually write things under specific users. Same thing, you use a path and you go through that. But the way to do that is that you would write, you would get the authenticated user's user ID and use that as a path. So I think it's something like, UID. And then that would be the path in which the data is being written. So if I was reading from it later, I would, read UID / whatever my data is. So you can nest this as far as you like, depending on how detailed your data is going to be, much like you would in a non-relational database. Now that I know that makes a lot of sense, actually. I should have read that. So we're leaving this as test for now. Let me go and paste this section into chat in case you want to paste this into your rules. And I'm going to remove the comments to make the chat message not ridiculous. But I would heavily advise you put that in your rules so that way you can follow along, or that you can make sure that no one's going to randomly read your database somehow, some way. You never know. Just, it's not good. And then we're going to go ahead and go back to what we have, which is, I'm going to paste what I had. Copy, paste, publish. Great. Now anyone who is authenticated can read and write to the test path. And I'm going to go now to administration or authentication. And I want to get started. Okay, so there's a number of ways things can sign in, whether it's that I'm using an existing login, which this would be great for our dash. This would be great for if we were doing something that had like a login screen for us to use. We don't have that. What if instead we didn't know who was going on? Like if we had anonymous, in which case anyone and everyone could do things. Phone, I don't really want to do that. I didn't even Google that one because I'm just like, you should not be using your phone to log in. That's so unsecure. But we are going to use email and password. Because let's say you have multiple people in your home, your roommates, your other roommate, yourself, and maybe you want all of you to have access to your automated garden or your automated light manager, or however it is that you're setting up your home, your house, it's your family maybe, and you're like, oh, I don't want to give access to my little sibling, but my parents should have access in case they need to see if the garage door is open, etc. Help your parents out, kiddos. I did not have such luxuries. My parents were tech enabled, and therefore I had I did not get to figure things out for myself because I was not asked. Instead, I was actually like not allowed to engage with it, which I think is very funny today, given that I ended up being a software engineer. Anyway, but we're not doing this one. We are not choosing an email link. And the reason why I'm saying this is we're using these little dudes to, these will log in. These will be given our credentials to log in, which means an email link is useless. This little dude cannot access our email link, but they can use, values we plug in. So go ahead and hit save on that one. And very nice that they're giving us multi-factor authentication. I don't know how we're going to do that on these without like a keyboard or, again, a phone, because we need this to authenticate every time we start it up. It's not worth it. Just do an email login. It's fine. If we wanted to have multiple sign-in methods, we could. We don't for right now because it doesn't make sense. Is there a safer way to do this? I have no idea, but the tutorial I followed said what seemed to be no. Who knows? And so right now it's not telling me anything because I haven't logged in or done anything. Nothing's been connected. Looks like there's also ways that I could change who interacts with it. So something I did run into when I was doing setup and testing emails out and whatnot was I needed to reset my password because I forgot what I put. Shame on me. But this email got sent out, and so I could change whatever the default email stuff is. I'm not going to because I don't need to, but this is a way that you can customize things, and you should be aware of it. This is the password. So this is the password reset one that I did see, and you can change all of those as you like, which is actually really nice. I appreciate how easy it was to access those things. Alrighty. I didn't actually read this last time. Good to know. Cool. So we're going to go ahead and add a user if I can talk, because apparently I can't. And so you're going to put in an email. It can be yours. It can be another person's email. It doesn't have to be the email that the database is currently hosting on, which I thought was interesting. You would think that normally like, oh, well, what if it's coming from, like this specific email I'm using? I don't know. You could make sure that. Can this do Google Auth? No, it can't. I don't think so, at least. If it can, I would like you to Google and tell me, because I don't think it can, but I would like to be proven wrong. Because a little microcontroller is not a human who can go access things. But that's my logic interfering with my ability to see if it's possible. So Google it and prove me wrong. I kind of, if it would be much more secure, I think. Anyway, email and password for now. And I'll show like what this will look like also in the code as well, and why we're using it this way. I don't know how to update the code for the other one, but again, I would Google it once again, proven wrong. But yeah, so email, password. Oh. So this is a just random stuff that I put in for now. I'll fix it to be an actual thing later, but you can see that I've been given a user ID. It tells me when I've created it, and you also see this little tab here where it'll tell me when I've last signed in, which once you start up your device, you would hope that it was last signed in when it started. And so it has this email where it will go ahead and send information to us. So if we needed to do that password reset, we can actually go ahead and do that, or we can see these options where we can say, hey, reset the password, disable the account, delete the account, etc. I'm going to go ahead and delete it just because I was proving a point. But yeah, so once you've added a user, which I've deleted for now, you don't have to do that. Your Firebase stuff is actually set up. This is actually like a 10-minute thing, if not less than that, if you already know what you're doing. But if you don't, because I didn't know yesterday, it took like 2 hours because I was like, why is this not working? But now that I know what's going on, I'm like, I can explain this to you in like 30 to 45 minutes instead. Great. Now you have what you need to have a functioning database. So, all right. So currently we have our temp sensor path of, value 100. Let's go ahead and change this actually to be the original path so I can prove what this is going to look like. Ooh, I can change that. Good to know. But I wanted test int 5, and the reason again I'm putting this back is because I want to show you like how this is going to actually interact. Float 5.5 add. Okay, that's ready to go. And then now is actually a great time for a break while I hook up the little server. I'll leave this running so that way I can actually see if things are working. But if you happen to stay on, you might see things changing. If not, go take a break to go get water, bathroom, all that kind of stuff. It's a human break while I set this up on my laptop because Arduino stuff. All right. Let me find that banner. Cool. So if you hung around, you will have noticed that these values have been changing. And that's because of some preloaded code I had that I set up to basically prove that the database worked, in fact, and that I could connect to it and prove that this wasn't a ridiculous idea. Because I've done a lot of IoT things, but I often have done it through like Hasio or Home Assistant, which fixes things. Oh no, I'm scaring people again. Oh no, I am sorry. I should have given it a minute. Might be. Let me open a new sketch. Okay, so hopefully Arduino doesn't make my computer blue screen. I try to avoid doing hardware things on Windows because Windows does not play nicely. And last time I was doing hardware, when I unplugged things, my computer blue screened. So we're not going to plug hardware in today. In fact, all of the dev work will be done on my laptop for that. And I will just share my screen when that day comes, which will be Sunday. Oh, I jump scared a couple people. Oh no, I'm sorry. I'm really sorry. Oh, I didn't. Is the audio still too loud then, or something else? Oh, all I wanted to do was have a functioning mic. Got off track. Let's go back to the checklist because this is the only thing that keeps me doing things properly. Right. Yeah. Okay. So I have code here. This is actually copied over from what I have on my laptop for the most part. But we're gonna go ahead and plug it in, and I'll explain what's going on while we're doing it. The only reason I am copying this code in and not like typing it in is because I didn't want to introduce weird bugs. Because it's harder for me to solve hardware bugs through Stream than it is for me to just solve software bugs. And I'm like, logically, if I just use the code that works, then it'll be fine. Logically, right? Let me also change the font size so y'all can read just in case you're elsewhere. Okay, so if you're not familiar with this IDE, this is Arduino. It is open source. It is a C variant language that makes it slightly easier to do hardware code. Because if you know things, you can mess with the system. If you don't know, it's a good way to kind of get started. Kind of think of this as like your main or your entry function. If you're familiar with Java or like Python, which has a main function, your setup function is, as it says in the comment here in this new sketch that I've created, that it will only run once. And then you have your main code, which will always iterate. And that's the case with hardware typically, is that it has a very small set of functionality that it will do repeatedly. Whether it's go get sensor data, go get sensor data, go get sensor, and it keeps doing that, right? Or it's go get sensor data, but if it gets this type of data, do this actuator thing. And then that repeats. And so it's meant to be small-ish. Some code can get quite lengthy. You might have more files, header files, etc. I'm so sorry. I guess I did jump into it. I hope everybody's back. I'm sorry. On the other hand, can I blame my PhD? Because I'm trying to submit stuff like next week and I'm having a panic attack about it. So I'm like, the energy has to go somewhere. Like, there are physics concepts involved here. Oh my gosh, that's funny. I feel really bad about that. That's pretty funny. I'm gonna have to tell my organizers I scared people online, and they're gonna be like, "How is that different from normal?" Okay. Putting my laptop away for now because it impedes me. All right. So, as with any code, you want to load up some libraries. And the nice thing about both Firebase and the ESP series is that there's already libraries in Arduino for you. So we're going to go actually find those. ESP32. And so I specifically have Espressif versions. And I think I actually have the library, so Espressif. And that's just a brand. There's a couple people who make different types of ESPs. Arduino also makes a ESP32 version. Will you pull up? ESP32. Search. Search. Oh, I'm looking for ESP32. I'm looking for boards. Good job. Yeah, so I already have this installed. So I'd be looking for the ESP32 by Espressive Systems. The ESP8266, I believe, is what I've been using, and I haven't had issues because it already, I mean, we can also just pull it up, ESP8266. As you can see, it doesn't pull up. The ESP32 series is fine. But I already have that. As you can see, there's other types of boards. You see how tiny this scroll bar is. There are so many boards out there, and there are more boards out there that aren't necessarily included in Arduino. You just need to have the zip file in the right place. So there's a lot of choices, which is why when I'm like, the latest thing that everybody's using is the ESP series, but what's to say people are still using that in a year, 2 years, 5 years, whatever. Anyway, coming back to libraries. Firebase. So Firebase, actually, I'm curious about that MongoDB question. Is there a Mongo library? No, there's not. So here's a drawback to using MongoDB. There is not an equivalent Mongo library for Arduino. That doesn't mean you can't use it. It just means that there's probably more work you have to put into it depending on how you go about it. So I'm using Firebase for the ESP32, which there's like a ton of Firebase integrations and libraries and everything, right? There's Firebase JSON, ESP32 client, client library. This is the one that I will be using, the Firebase Arduino client library for the 8266 and the 32. But as you can see, there's lots of other people who are writing their own variants of the library for whatever their use cases may have been that the existing library didn't support. I'm using this just because that was what the tutorial used, and I don't know much about the other ones. But if I were to research, perhaps they might have been a better pick. So while that does that, that will take a hot minute. We're going to go ahead and look at anything else that we might need by cheating with my code, which is to say, I think we're good. So while that does things, I'm going to go paste this in because, oh, did it finish already? Wow, that was so fast. No, it's not done yet. It's indexing. Okay, so if you are familiar with C and C++, then this is actually quite familiar for you, where it's like, oh, these are default files or default header files that like you have. But I'm also using, if something is defined, use a specific library, because if I'm using an ESP32, I can use just the base Wi-Fi. If I'm using the 8266, I want to use their library for the Wi-Fi. Just because it has different configurations and ways to initialize things that may not be obvious just starting out. So try to use what you think makes sense or what fits your needs, because if you're using the 8266 and you know you're going to use it, you don't actually need all of this code. If you don't know which one you're using, which yesterday I had no idea which one I was using, it really depended on what wire or what cable I had. Because as you can see, maybe this one is a USB-C, this one is micro USB. I think it's that the 32 is, are these both 32s? No, the 8266 that I have is USB-C, which is very nice, but I need a data cable for that, and I'm not sure where that cable is because it wasn't in my drawer. People have rummaged through my drawer, and I don't know where things have gone. The answer is me. I have rummaged through my drawer. I don't know what I've done with things. And then the micro USB is the the ESP32 that I have. So I have a data cable for that. Cool. So things are downloaded. Great. We can go back to our file system. We don't need to worry really about anything else for now. So we'll go ahead and close that. And I'll introduce you a little bit to the UI, which is there's a serial plotter, which is great if you're looking for values over time, or you're looking at maybe understanding like a voltage or something. There's also the serial monitor, which we are going to use if we get this working in time. If not, I'll show you next stream. But if we are sending data, such as us sending data to that database, and we want to print it out, much like we would and see what's going on, because gosh, how do you print things out on like, you know, a microcontroller? You don't have a screen to see it. Well, the serial monitor does that for you. The serial monitor is basically your debugger. So it's like hardware is software coding, but slightly harder because you don't have all your comforts, basically. And that's why people are like not happy with hardware. But yeah, So this is what will tell us when like things are uploading and flashing the drive and whatnot. And then if we do have something connected down here on the bottom right where it says the dev module and COM5 is not connected, eventually it will say that it is connected. I do have this using the ESP32 dev module as far as the board version. That's important. But as you can see, I could select another board and port. Right now there's no ports. That's fine. But again, remember that like board library I said? There are so many things you could pick from. So many. So many. I'm only reaching the E's. But yeah, so all I have to say is just because you're using one board that's not what I'm using, you can kind of make it work. There's probably tutorials. Your needs vary. So if you don't get your hands on an ESP, that's fine. Chances are you're going to find something that's also good. Arduinos are very accessible compared to a lot of the harder boards that are out there just because there's different ways that you work with them. We're not getting into that. We're just getting into what do we need? How do we get this tested and working like what I showed you? And the answer is we're also going to need some information, such as all the keys and passwords. So this is where that question came up again about like, hey, how do you connect to your Wi-Fi? Well, you're going to need the name of the Wi-Fi and you're going to need the password to the Wi-Fi. So if you have this stuff, you should probably make a guest network or an IoT network or even like consider other ways to do this. Again, to not give access to your personal Wi-Fi. I'm not doing that currently because I am lazy. Don't practice. I don't practice what I preach, but you should practice whatever. The other thing that we have is the email and password. So I deleted my user, but when I was helping you set up the database, I put in something. You could, if you wanted, make a special email for your ESP where it's like IoT such and such, IoT Cecilia's home or something at gmail.com. Use this like specific password that I'm just dumping it in. And the only thing that is ever using that email and password is this specific code. In which case, you're not using your personal email. Fantastic. This is a great way to obfuscate some user stuff from your database accepted users as well. That way, anyone who maybe has access to your email, like if I put my personal email as far as a user, and I also put it here, if anybody got into things, they could technically have access to my database. So making custom emails for projects is actually recommended because then as long as you have that access, which is on this code, you're good. And so that I don't mean the login password. I just mean a password for the database that you set up when you created the user. Two completely separate things. Please make separate passwords. Anyway, you also need your API key for the Firebase project. And I did not show that to you, but if you go through your project settings, which let me go ahead and double check that I'm saying this right before I dox myself with that. It is under project settings. Yeah. If you go to project settings on your Firebase setup, you'll see your project name, your project ID, the project number, and the web API key. What you would do to replace here is just paste that API key right here. And moving on again, let me make this here so I can see that again. The other thing you're going to need is your database URL. So all these defines are setting up constants that will technically never change. In fact, they shouldn't. These are all things that we are like, these are things that can never change. But if I do need to change them later on, I can just update it in this one spot. That's just good coding. But the thing that you'll need there is you can find that by going to your real-time database. And in our case, this is the wrong one that I was looking at. Oops. Let me copy this, please. Yeah. So that's this URL here. You see that it says default RTDB. Why is that hard to say? I'm going to copy it. Copy reference URL. And that would go here. And you see that I left a note for myself. There should not be a slash. Freaks out, I think. Do I have a slash in mine? I just closed the code. I don't think I have a slash in mine. I think it automatically appends path stuff for me. So anyway, so this is where you would put your stuff to access things. And so you'll notice that we haven't even gotten to like any of the main code like setup or anything. Let me also like remove this. Can I remove you? I don't want to see the output. Ugh, it's not letting me remove that. Boo! Okay. But again, you'll see that we haven't even gotten to setup. We're doing all of the pre-setup to the setup code itself. Like we haven't initialized the Wi-Fi or anything. We're just setting up all the things that we're going to need, right? And the things that we're going to need are, which again, is very nice that they have this library. We need all this like Firebase, the data object. We need the authentication and we need the configuration. All of these amount to connecting to the database, sending information, etc., and doing, of course, the login based on this being us with our email, right? And so, hello, we finished setting up our Firebase database, and we are now working on setting up some some cobbled together code from 3 tutorials to prove that our database works so that way we can have a strong start for our second stream where we actually are getting sensor data and doing something with it. So normally we would make a .env file. That is what we should do. Arduino is kind of gross. Arduino, no one's going to ever access this code except us. And the code that's uploaded to the module, the ESP32, is sent as compiled code. So unless you're using a reverse compiler, do you need it? Not really. No. It's good to have it, but you could set up a header file because it's in C. So your .env file is kind of different. There are many different ways of making this better. This is just the way that I went about it because I'm like, well, if I'm flashing it to the ESP32, I don't really care about making a .env file and making that work because I don't want to fight with Arduino. However, that may be a better way to do things. That may be a way more secure way to do things. It could be that it's a separate data object somehow. It could be a header file. There's a lot of different ways I think that I would probably go about this differently in the future. But for the sake and purpose of tutorial, I don't really care. Which is a terrible thing to say, I know. But that is the gist. Like we are doing the .env part of stuff, basically. And then we have some basic variables that we need for proving that the stuff actually works, which is that we want to send our data, and we're sending it in intervals. Like what's going on that I was showing you during break was that I was sending data over intervals and I was just updating what it already existed. So I wasn't sending new stuff, so to speak. And then we have the user ID, which we're doing this. We're keeping this specifically as a way to make sure that our user is signed in and that it matches. Because if the user is ever someone that we don't expect or that we don't want, then we might write a condition that says, hey, don't accept this user. So when I had made the additional user with the login and password before I deleted it, which again, you don't have to delete it, there was a user ID that was there. And you could copy that and say, as long as the user ID is equal to this user ID, then let them do what they want. If it doesn't equal that, because maybe someone's hijacked something or changed some code somehow, some way, who knows, then don't send data. Say that there's an error or however you'd like to handle that. We currently have the error handling through the rules on Firebase. But if you're feeling like you want to be extra secure, that might be a way of approaching that. And you'll see what I mean a little bit later when we write out like the serial stuff. Okay, now we get into the stuff that I kind of know. We can delete this, which is that we want to set up the serial. And so we want to say, oops, begin. And so you see it gives me a little bit of information, right? Just like we would Visual Studio Code, which you can use boards, etc., and set them up with Visual Studio Code. I have never done that. I cannot fathom the idea yet. I'm working my way toward having all of my things be on one IDE, but that feels weird. I just don't know. It feels weird. So serial is basically our printf or our print statement or a system.out.println or what have you. Whatever your preferred language is, this is our print statement. And this is what will appear in the serial monitor when we finally open it. This is what we see in our terminal if we were, again, doing software and not hardware. But this is how we get access to what the heck's going on while it's plugged in. The moment you unplug it and put a different power source that is not being plugged in to, say, a laptop or a desktop, means you have zero access to any of this output. So that is a caveat. Because normally you can leave print statements in and, doesn't matter. Like you can see it however you need to, whether it's in the console or in your terminal. There is none of that. This is the only place as long as it's plugged in here. So keep that in mind. What is in chat? Oh, advanced simulator. Ooh, I have never seen this. So somebody in chat, so thank you for that. Abhinav, you just shared what looks to be a online simulator of a number of different microcontrollers that people like to use when they're just getting started. Cool. I will play with that when I next do a hardware project that I don't have stuff for. Although I think I have most of these. I think I actually have most of these. I collect microcontrollers. Can you tell? Oh, were you asking which what's it called? Which microcontroller is best? Did I misunderstand your question? It depends. I like using the ESP32 because it has Wi-Fi and Bluetooth. But I think Arduino now comes with that on certain boards. So if you get a really, really tiny Arduino, you probably won't have Wi-Fi and Bluetooth. You might have one or the other or neither. If you have the Mega, I think you have everything. The Pi Pico is a very, very tiny Raspberry Pi, but I really don't use Raspberry Pi for hardware these days. I like the idea. I'm glad that they made it possible, but it's just so frustrating to work with for me that I prefer Arduino variants, like the ESP32, Arduino itself, at Mega, etc., like microcontrol, like all those kinds of things, over Raspberry Pi. If I'm going to use a Raspberry Pi, I'm going to use it to make a server. I'm going to use it to make a Pi hole, to collect ads. I'm going to use it to manage my my Home Assistant server, because I just think a Raspberry Pi is better suited for those things. You can do hardware things with it. I just don't like doing it. But people have different opinions, and it's very much a what best suits your need. That's not part of this workshop series of how to choose hardware, but it's like choosing a laptop or a desktop computer. Like if you build a desktop computer, you want to choose how much RAM you think you're going to need. You need to choose how much memory you think you're going to need. You need to choose like how fast it needs to run. Does it have 1 or 2 cores? All that kind of stuff. Because that impacts how this really, really tiny baby computer works, which is why the ESPs are really nice, because they have the memory to like handle a Firebase library, right? I think an Arduino Nano probably would struggle because you'd run out of space. So think back to before our time. Note how I'm not saying before my time or back in my day. When computers were really tiny, they were in kilobytes. This is the kilobytes point, where this is the modern day mini computer, like kilobytes in size, not gigabytes or petabytes or terabytes that we have today. So yeah. Semicolon. Okay, so what you didn't see was baud rate, and that's the rate at which information is sent back and forth. So there are 2 choices that I usually go with, which is 9600. That is the slowest rate, I think, or among the slowest rates that is preferred to send information back and forth to Arduino, ESP, etc. The more common one that people tend to do, which is a faster rate, is it that? No. I forgot the 200. Is this baud rate. This is literally just a frequency. Again, this is just how fast is information going back and forth, because let me go pull up the serial monitor. I actually don't think it'll show me the serial monitor. Yeah, I'm not connected right now, but there is another, what's it called? Drop down that it would show when I'm connected to a component or a device on the right side here, that it'll say baud rate, BAUD, baud rate. And it will, you want that rate to align with what you put here, because otherwise you're going to get garbage. And I mean garbage. You will not get text. You will get garbage, because it's not the speed it's expecting data at versus the speed that data is being sent at don't match. So it doesn't know how to translate that into text for you. So serial is important. Okay, So I got over that. Now we want to set up the Wi-Fi. Let's also begin. We want to now use our setup, and we need the Wi-Fi password. And these are, again, default libraries, so we don't need to worry too much about it. Are these the right variable names? Wi-Fi SSID and Wi-Fi password. Wi-Fi SSID and Wi-Fi password. So this is, again, a library. The .begin function just takes in those things. If I were to get rid of this, will you give me a preview of things? Or will you freak out? .begin. Oh, you're not going to do that. Great. Okay. Well, sometimes it will give you previews, sometimes it won't. But the point is we need to put in that stuff. And then, again, our print statements could be, so you can see we have different options. Oh, thank you. You're right. I forgot to unpin it. I can put in a number of different options. I'm going to do a print new line, and I'm going to say initialize Wi-Fi connection. So we want to make sure that that happened. And then I'm going to copy this bit because I don't want to mess it up because there's some things here. So it says that while the Wi-Fi status is not connected, this is a value that comes from the Wi-Fi library. Notice that we obviously didn't include that in our setup. It comes from this or this, which basically says, hey, if you're not connected, keep trying to connect and just have like a little loading sign. We also introduced delays on purpose. We don't need to do this in software, basically. In web dev, in mobile dev, delays aren't really needed. But if you play games or you write games, you do need delays because maybe you're like, oh, I need to make sure if something's loaded. Because if we didn't have a delay, it would put dots at the speed at which it processes. Great. Not so great if you don't want to fill the screen or overload things or prevent it from doing things it needs to do. Again, you're working with little baby computer, which means if you don't give it a chance to think, it's not going to actually like have that extra moment to like, oh, I need to switch tasks. If you've had a chance to do any assembly, you'll know that this delay is actually quite awful in a different way. If it's in your like loop, it will prevent other tasks from happening. Because again, this is one core, 2 cores. How are tasks being managed? This is like little baby load balancing, right? There's lots of little baby parts to it. Anyway, so we have our while loop, pretty standard. Again, this one I just copied because I'm like, I don't want to mess up this specific line. That one's standard. And then if we wanted to do any print statements, we could get like the IP address. We could say like, it's connected. There's a variety of things we could do. But this basically says, while there's no connection, don't move on. And then let's go ahead and jump to actually using our data. There's so many extra enters. Okay, so we have config, which will take our API key, our database URL, so that way it can access things. So remember how I said like we're gonna need to do post requests, get requests, all that kind of stuff. This covers that for us. This library just obfuscates that for us, which is great. But we do have an authentication where we need the user and email. The tutorials I cobbled together, one of them did not set up an email, password, etc., which I'm like, no, don't do that. That's bad. That's really bad for security. But it would prove the point of, do you really even need that to connect to a database, which you don't, but it's bad practice, so don't do that. So they didn't have that set up, so I had to go hunting for a solution for this one. Anyway, so we have our auth user and our email. We finally are starting to use those .ends, basically. And now we can get into actually setting up Firebase itself, because we've set everything up that it's like Express when we're setting up the URL and getting all the keys that we need. You know, we're getting ready to set up all the paths that we need, the get, etc. That's what this library is doing for us. If you do want to look into things, though, you can go to the definition, which it's not telling us. Great. Sometimes go to definition. Come on. Sometimes it will open a header file. It might take a minute. Come on. Will you show me? Nope. Okay. Some libraries you can, some libraries you can't. I want it to show me. Okay. Google, GitHub, probably exists there, you can generally look at the code behind the scenes and see what's going on. It is disgusting to read, as any library is, which is unfortunate. But the point is, you can get a better understanding of what's going on if you didn't have me doing this for you, which I got from a tutorial, you would have no idea what you would need to do. I kind of hate that it's not backlinked. So I usually do a lot of Googling on libraries to be like, how are you working behind the scenes? Because I need to know what's going on. It's almost like I have a cat to mimic. I make fun of her a lot. When she makes noises, I make noises back at her. Okay. I actually can't explain this one, so I'm going to go Google it to prove my point. I don't know what Reconnect Wi-Fi is, and I want to know. So we're going to go Google it. Make sure it's documentation. Arduino. Okay, this is what I mean. So I went and Googled the Firebase Arduino client library, where I'm like, I would like to read the documentation. Voila, a GitHub. Oh no, it's deprecated. We have moved to a new library. We recommend it for ongoing supports. You have to read it library. The new async Firebase client library. Okay, let's go read that. Who is this by? This was like a very recent tutorial. All right, but let's see now. So we have source. And I want to go to, this is, what is this under? Firebase.reconnect Wi-Fi. Let's go to core. Where would this be? Maybe database, data options, real-time database. Hey, this is what we're working with. Does this give us anything? Real-time database, service URL, redress, get, reconnect, Wi-Fi. Nope. Great. Functions, options, storage. Wi-Fi. No. Great. It's not in here. Okay, so we have Firebase Wi-Fi. So where is this used? Messaging? Data options? Firestore? No, because we're not using that. Oh, network probably. Yeah, here we go. Okay, so I found it in network. As you can see, this is disgusting. Just flat out. Library code is just disgusting. Because you're importing a lot of things. You have a lot of if defines. You have a lot of like, if this, then that, then this, and this, and this, and I hate it. Because you can see all these people have different boards. Like, it's great that there's support, but like, there's so many boards. This is all set up for those. If they're doing these things, it's all defines. Defines. Okay, I just want to see, is it available? Okay, so we have that if connected stuff. There's that. I didn't want that. Don't do that. Show me, thank you. No, don't collapse it. Man, okay. Anyway, so it looks like they're doing a different setup. They have Firebase Wi-Fi. I should have used the original one. Whoops. Is there a reconnect? There we go. Okay, so this function reconnect is the only one that exists. They're saying if the credentials are appropriate, disconnect and reconnect. So I'm guessing we specifically want to call this connect function, and it's more efficient than just saying disconnect on your own. Perhaps in case it already tried to, maybe, or something else happened, or we just want to have a clean start. This is kind of like clearing a cache or clearing a queue that I can think it would be, just because of like past experience with hardware. You usually want to flush a queue, and I can see this being one way to do so. Okay, so I've proven that you can go Google the original source code. You're just going to hate your life. But now we know what this does. It literally reconnects the Wi-Fi, but I wanted to make sure, like, does it actually do that? Because sometimes libraries are badly written. Yeah. Anyway, so the other thing that I'm pasting, because I don't want to mess up, is this config status stuff. We have this usual begin. Everything in Arduino, by the way, like a keyword is .begin. That's like your initializer, your setup, your start a service, etc. But what I'm looking at is this token status callback and max token generation retry. And this is actually quite similar to what we would normally see in like a web dev approach is that if we don't have a token, we don't want to keep trying until the end of time. We only want to try it a few times before we're like, all right, it's not working, give it up. And that's kind of the case here. It's like, if we're just not getting it, then just don't continue. But there is something I forgot to add, which was the token information itself, I think. Did I add that? No, I didn't. That was a library that was missing. So let's go add that. Again, libraries at the top, So this is a token helper and the real-time database helper. So I'm guessing these are the things that were now deprecated. I will debate whether I want to update our library use, but if it works, don't break it. If it ain't broke, don't fix it. So I'm not gonna fix it because it's not broken. But we need those tokens to actually say, like, give us a functioning connection, right? Let's see where we're at. Yeah. And then the last thing I wanted to add was, hey, let's go ahead and confirm our user ID actually matches what we want, because that's important. So we've started the Firebase connection, and we're going to say, get the user ID. So once that token is generated, the handshake is completed, things are confirmed, then we want to go ahead and say, like, go get the user ID and say, like, who is it that we did the handshake with, right? And once again, introduce delays while it's figuring out whether it's connected or not. What if you have an OLED display module? Please explain. What do you mean OLED? Oh, like, do you want to display text like using a display module? Is that what you mean? It's a screen. Yes. So screens. Wow, I love screens. Okay. Screens work until they don't. Screens are one way of displaying data, yes, and interacting with that like output. If the libraries are good, then you can write whatever you want. You could even draw stuff. If there is no tutorial or no libraries, you get to do it yourself. I don't know about you, but I hate writing libraries, and I don't want to figure out a display module. I hate it. Like 7-segment displays bother me so much because I'm like, I have to coordinate every single little pixel and piece and segment, and I'm like, I scream. So I just kind of wing it and hope it works. Because yeah, screens are good except the blue screen of death, and also screens that you have to write the library for yourself that write what you need to write on them. And so if you have to write it yourself, it's not a good screen. But yes, you can use them. I think Adafruit screens are usually pretty good because they already have written the library for you, but their tutorials could be better. Their data sheets are very lacking. So if you do get a screen, make sure you have a very nice data sheet that tells you how to use it and what to do. Or wait for someone who's way more into this than you to do it for you. That's kind of how I go about that. Anyway, we have finally finished our setup code. It took us like 20 minutes, and I was mostly copy pasting the code because I'm like, if I mess this up, we're never figuring it out. Because setup is really important. So there's different ways that you can go ahead and go about testing this. Normally, you just paste it, hope it works, and then figure out the error messages if there's good error messages, which is what I did, and fixed a lot of the other issues with it because it didn't initially work. Again, cobbled together. But again, this is broken into parts. First, make sure the Wi-Fi is connected, right? Next, set up the stuff for Firebase and then connect to it. And then once you've connected to it, make sure that it's only trying to connect a few times before actually saying, go ahead and start, make the handshake, let's start sending data, right? And then this is more for our side of things where we just want to see who connected. We want to make sure it's us, because if it's not us, oh no, that's bad, right? And so for our loop, we could do things like, you're connected, right? As a very simple thing. But because we want to actually connect to the database, and we want to use some of the initial information that we had, we want to make sure that we check if that database is ready. And this is again, a common way to test whether or not things are working, regardless of whether you're using Firebase or not, which is that you saw that we used delay earlier. Like we're saying delay 1,000, which is I think 10 seconds. This one is delay 300, which is 3 seconds, because it's in milliseconds. The way that we're doing this here is we're not actually using delay. It's actually bad practice to use delay in the loop. Instead, it's better to get the current milliseconds, subtract it from your previous milliseconds, and then check if it's above a certain value, or like if it's gone back to 0 for whatever reason. And then based on that, do stuff, right? So that's what this is doing, where the additional piece is that we're saying, hey, is Firebase connected? Are we good to go? Has the handshake been made? Are we authorized? Are we good? If so, figure out how much time has passed and then do the thing. The thing being where we want to update our integer. So we're just going to copy that bit as well because we're running out of time. And I want to make sure again that things work the first time. Can you tell that I'm tired of streams where things don't work? I'm so tired of having to debug on stream. We're going to end up debugging, I think, when we do the sensor stuff, because I think that will take a bit more time, but that's okay. So what this is doing is right now it's in the wrong condition, actually, is that we actually need to move this here. This is here. And what happened? I'm missing it. Okay, well, something happened there. Let's go fix that. Anyway, now that I've fixed my curly braces, go figure. We want to update that integer number on the database. So remember we said path int? Somewhat. The magic of delay is literally pushing pause. Push pause to do something, right? And so the reason the delays are inconsistent here is because we have different things that we want doing. This is during setup though. So right when you give power to a device, it will go through that setup function because it's like, oh, I need to initialize. What do I need to do? And the reason it has it pausing is because we want to give time for things to connect. Wi-Fi does not connect fast. You've seen it on your phone where you're like, I put the password in and it still says connecting. It still says connecting and you keep checking. And so that delay is to stop the like check issue where you're going to actually just break things or risk being kicked out of things, especially if you are like confirming, what's it called? If you're confirming, like, I lost the train of thought on that one. The point is, delays are important when you're doing setup because you don't want to keep calling functions you don't need to call. You just need time. You need to give time for things to process. But you really don't need to do that for loop of like, hey, how many milliseconds has passed? Oh, if so, then do the thing. Delay is fine for setup. Where it's not fine is in the loop, where you might say, oh, hey, instead of doing this check, we might say delay 1500 or something. Delay 15 seconds between data. Because we're using it in the loop, it's like full pause, don't do things. Which if we have other things that we want going on, this is bad. And I keep saying this is bad, and I don't mean to say it like as a like, do not do this, warning, whatever. That's not it. But like, yeah. So with loops, you want to say how much time has passed. If enough time has passed, let's do the thing. That way, if there's anything else you need to happen, it will happen without the whole system being like, we're just sitting here waiting because you told us to wait. The thing I always tell my students when I TA'd was these specifically the hardware, your ESP, whatever it is that you're using, it is a child. It is a 2-year-old, which means if you tell it things, it will do exactly that thing, which is a problem, because it might not. No, it's not seconds. It's actually milliseconds. Delay is always in milliseconds. So if we were to convert that, I think it would be something like this much. I think 150 seconds or something. I say late, but I don't actually mean it. I try to scope workshops where I'm like, hey, I know we're going to have a lot of questions leading into this. Let's spend the time to really understand this. So that way, when we get to the actual thing where we get to have fun and do more live coding, we don't have as many questions, and anybody who's like behind can go watch a previous stream. But I like answering questions because I would rather that you understand even if this stuff doesn't work. But it does work. I did purposely test things lots of times. But yeah, no, I enjoy the questions because it makes sure that I'm not running too fast, and it makes sure that I'm like, now I can kind of start to scope things such in a way that people who care about this can actually understand it. Or if they watch it later, they're like, oh, I wish I could have asked about this, but you've already explained it, so I don't have to ask, especially for people who are watching it after the fact. Anyway, so to the original point, we are checking if an amount of time has passed, as well as if the Firebase is ready for us to do anything with it. Because if we didn't do this check, we would be talking to the Firebase, the database, and it might be like, yeah, error, because who are you? You haven't authenticated, or error, like we don't do anything or whatever. Like, why are you talking to us? We don't know who you are. Like all sorts of different reasonings. So we want to make sure that the Firebase is in fact ready to talk to us. That enough time has passed, whatever time we're expecting it to be. This should actually be a variable that we say like interval between data sending or something like that to obfuscate that. The millis section just gets like milliseconds since I think start or something like that. And then we're going to change the value, which is what you were seeing happening. Every 15 seconds, it was changing the test int path. And oh, let me go delete this also. And this is from our side for the serial line where we're like, hey, did it do the thing? Where is it sending? And what type of data is it sending? Right? So we're not updating the float bit. We're just, again, proving that this works so far. I want to test this, but I'm really scared of blue screening my desktop, given what happened last time. So we're not. But I do know this code works because it's running on my laptop in the full capacity, and we have copied everything over from my laptop. Therefore, it works. So if you are following along or like you're watching this later, you can technically test this code. I would just tell you to go ahead and first let's compile it and see if there's any issues, because I've probably forgotten a semicolon somewhere. And then I would, once it compiles, I would upload it, because then it will compile and then upload. I just need to make sure that the ESP is connected. And then in the serial monitor, we would be seeing that text, that serial print line, etc. This was a good idea if I can connect to StreamYard with my laptop in less than 5 minutes. Let's see it. Let's see if it works. Or I need to not show you the code though, because it has some private stuff. I don't want it to. It has my Wi-Fi password, and I don't want you seeing that. Actually, wait. Let's not do it that way. Let's see if this works the way I want it to. Let's do that. Let me set up my laptop for this and see if. Yes. Okay, great. Autodesk? Isn't Autodesk like a designer software? AnyDesk. Okay, cool. Because I was really confused. Let me log into StreamYard on my laptop and see what comes up. Let's see if this happens. I will show it for next stream. That was my plan, at least, to have my laptop hooked up and ready to go, because we will be doing more. Wi-Fi was not declared in scope. What do you mean? Where? Did I not? Why are you doing this? Okay. Anyway, to what I was saying, yes, I will show my laptop next stream, because I will have it set up. I didn't plan on it for this stream because I'm like, I can show you what it is working with, and we can piece through the code, because it is the working code. Although I don't know why it's freaking out about Wi-Fi. Oh, did I not? Do I have to download this? Did I never have this downloaded? That doesn't make sense. Why are you freaking out? Well, I do know it works because it is flashed on ESP32 right now from my laptop. Something I missed then. Did I misspell something? I didn't really type much. Let's go get this line then. Maybe I did type it wrong. Oh, it's because I spelled it wrong. Because it's an F. This is why we copy things, folks. This is literally why. Ugh. Once it compiles, we're going to call it good and log off for the day. We have played with fate enough today, apparently. But yes, I will definitely be sharing my laptop on Sunday. So Sunday, my hope is that I will get at least the temperature sensor, if not the sound sensor, ready and rolling for y'all to take a look at, see what I did. We'll talk more about how that was set up, and then we'll actually integrate it into the Firebase database. And that is such a mouthful. With the intent that by the third stream, we'll be looking at like, well, how do we represent the data on something that we can access on our phone or on the internet, like on our desktop, so that way we can actually use something, right? You need to be able to do something with it with the intent that you would be able to go off and be like, here's a report of our data usage in our home. Or, hey, the garage door is still open. Here's a widget. Or, it looks like it says it's going to rain. All sorts of different applications. This is very much a starter kit, like I had mentioned. And so to close up, while that's compiling, because that's going to take a minute, if you haven't checked in, I can find it. This one. I will see if my hue lights still work. It's been years, and I don't even know if the app is alive. But I will see what I can do with the Philips Hue light for the next day. And AnyDesk. The fast remote desktop application. Oh, okay. I have something else for connecting to my laptop. Which I could have used that. That would have been smart. I have a different thing for connecting to stuff remotely. I still like the idea though of using StreamYard though, because then I can just fix with the windows and whatnot and choose what windows I want to share. So I have a little more control. But coming back to this, I will do my best. I cannot promise because I'm literally writing my dissertation. So life is a bit messy, but it's fine. This is my break for me to have fun and do hardware projects because it's been a while. But yeah, any last minute questions? We've got like less than 5 minutes. It's finished compiling and there's no issues. Great. So technically this would work. Whether or not it would actually send data or not it would tell us if there was any issues with some of the other code that I have. Let me also make a note in the, I don't have it there. It's here. Let's also do that. Let me make notes. So we have integration with sound, temperature, hue lights, servo, specifically sound and servo, and then temperature and hue lights. If not, then RGBA. Okay. Alrighty. Then with that, thanks everyone for hanging out. And I know we didn't do a lot of active coding, but at least we were productive and got a lot of stuff set up. We will have less active coding and more active debugging next stream, I expect, and probably the third one. But do I have plans on working on the mini pupper? What's the mini pupper? What's the... What? Wait. No, that's so cute. This is it, right? I love him. I want it. Oh my god, I want it. This is so cute. How much is this? Do I have money? I don't have money, but I want it. Ugh. That's expensive. I don't want it that much. I don't want it that much. Maybe I can 3D print the parts? I mean, I need to learn 3D printing. Aw, that sucks. You know, it's probably a matter of like shipping the parts themselves is pretty hard because like some hardware is under a lot of like control, like what's it called? I don't remember the word. My brain is crashing. We were at the end of 2 hours and it shows. I don't think you all are dumb. Don't say that, please. But I like teaching, and this is my chance to teach, and also to learn from other people because sometimes people in chat know more than me, and I welcome it. But we are also at time, and yeah. Thanks so much for coming. Thanks for entertaining me. Lots of good questions today, and I look forward to what questions y'all have next time. I don't know what's next, but you are welcome to pull up the schedule. I will probably see you Sunday because that's when the next stream is, I think. Or I have Tetris. I can't remember. It's in my calendar. It's in my calendar correctly this time. Cool. Have a good one, y'all. Make sure you take care of yourselves and see you next stream.